Remember our function notation? If not, you're going to remember here in a minute. We can use function notation with polynomials. What do I mean by that? I'm going to write the problem down. That means function notation. If P of X equals a polynomial, notice it's a trinomial, 3x squared minus 2x minus 5, find P of 1.
So the P just stands for polynomial.
I just made it up. Doesn't mean it could be f of x, g of x, anything. I just made it up.
Is there ever a reason why it's a specific letter, or is it just whatever?
Whatever. If you have multiple polynomials in one problem, they all need a different letter. So one would be f of x and g of x and h of x or p of x. They all can't be f of x.
Okay, and the only one that matters is the one that's in parentheses because that's the one that you're solving for.
Exactly. So see the x here? I don't have x anymore. I have 1. That means x is equal to 1. So we're just going to plug it in and find the answer. This is a shorthand for saying, hey, take x equals 1 and plug it in. And that's all it's saying. So we are going to do 3 times 1 squared minus 2 times 1 minus 5. And it's going to be a numerical answer. So exponents first, 1 squared is still 1, minus 2 times 1 is 2, minus 5, which is 3 minus 2 minus 5, which would be negative 10. And how you can write the answer, you should write the answer, is P of 1. So if I took my P function and I put 1 in, I'm going to get negative. That's not negative 10. What am I talking about? Hold on. I dreamt up a negative sign. Hold on. It's not negative 10. 3 minus 2 is 1, negative 4. How's that sound? Negative 4. My eyes, when I looked at it, I saw negative 3 until I looked up again. So you're saying with a function, if I plug in 1, I'll get negative 4 out. I'll call that number 1. I'm going to do one more. I'm not going to do too many of them. They're all the same using function notation. This one is a caution. This one's one that a lot of students get wrong, so I want to do it. Okay, so if f of x is equal to negative x squared plus 4x minus 2, find f of 3. Now, this is where you have to be very extremely careful. That negative is not with the x. So you're only allowed to replace x with 3, just x. So that negative is going to hang around and become this. You don't have negative 3 squared, you have negative of a 3 squared. That means I have to do my exponent first. That's 9. So the negative stays, negative 9 plus 12 minus 2. That's what you really have. That negative does not become positive. A lot of students think, oh, it's negative 3 squared. It's positive 9. No, it's a negative of a 3 squared. Another way to look at it is this. It's really negative 1 times 3 squared. That's what it's doing. They're separate. They're not together. It's not negative 3 squared. Okay, so that would be 3 minus 2, 1. So I can write the final answer. F of 3 is equal to 1. I'm just gonna do one little note on combining like terms. Combining like terms with polynomials. Basically, when you add or subtract, multiply, we're going to do after this. When you add or subtract polynomials, you can only combine terms that have, I'm going to say the word exactly, that's not exactly, have exactly the same variable. I'm going to put an S on there because it could be more than one, and exponent. And I'm also going to put an S on that because it could be more than one. They have to be identical. Same variables, same exponent. No. When you add and subtract, you never change the exponents when you add or subtract. Really, 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 really important. Let's do a couple examples. So we'll say simplify. I'm making a big one. So while you're writing this down, just to listen, when it's a like, when you consider a polynomial term to be like a like term, they have to have the same variables with the same exponents. And when you add them or subtract them, you never change the exponents. It just stays the same. So if I'm looking at this term, xy and xy, they both have x, they both have y, they both have a power of 1. X to the first, y to the first, right? So I can add those two or subtract, whatever we have. I can put them together. So negative 4xy plus a 5xy, think of it separately. What's negative 4 plus 5? Okay, 1, which means I have 1 xy left, which I'm just going to write as xy. We don't have to put 1. And then we're going to look at, let me see my next color. We're going to look at x squared y and x squared y. I can put them together. I can't put this together because this has xy squared. They're not identical. But look at this, 3x squared y minus 3x squared y. Well, they actually cancel out. So we don't even need them. They're gonna go away. And the only thing left is this, plus 7xy squared. Now, what is the standard form for this? Oh, good question. What is the standard form for this? Which one has the biggest degree? This, if I add up the degree for this term, is 2. If I add up the degree for this term is 3. So this one has to go first. So to be in standard form, I have to rewrite it as 7xy squared plus xy, because this term had a bigger degree than the other term. Okay, so two things we're going to do next. We're going to add and subtract polynomials. that all this stuff led up to adding and subtracting polynomials, making sure that you're combining like terms, and not adding and subtracting the wrong things. So I am going to add a page. So we're going to start with adding polynomials, and then we'll bring in subtracting polynomials. I think after we do adding polynomials, we'll take a little break and then we'll come back to adding and then finish the next section, which is multiplying them. So we're going to add polynomials, then we're going to subtract, and then we're going to multiply them. And that's the end of what's on your exam. All right, so to add polynomials, we just combine like terms, right? We will combine, like terms. And this is what it means. This is what you do. This is what, when it says add polynomials, this is what you have to do. You have to combine like terms and write the polynomial in standard form. Again, I don't know what your online work will do, but you should always write it in a standard form. Write down the first problem. Okay, we have two polynomials. They're in parentheses. I'm going to show you two different ways to add these. The first one I'm going to do one way, the second one I'm going to do another way, and then you can pick whatever one you like best. So do I need the parentheses? No, I'm not multiplying. How do I know I'm not multiplying? See that plus sign? That means I'm adding. I really don't need the parentheses. They just give you parentheses to say, hey, this is my first polynomial. This is my second polynomial. Add them together. But we really don't need it. For adding, we don't need our parentheses. Notice I said for adding. We need it for other things. We don't need it for adding. So just to make it more clear, I'm going to rewrite it without parentheses. Now, a really good habit to get into, and it takes a little while to get used to it, is do the problem in standard form. So look for the highest exponent. My highest exponent is a 2. Do I see any other x squares? No. So that's going to be my first part of my answer because it'll be in standard form if I do that. 4x squared would be first. And now I look for my x's. I have a plus 3x and a minus 3x. Well, that just cancels out. I don't even need them. That makes 0. I already did that one too. By the way, it's a good strategy too. If you like it, you don't have to do this. You can cross them out as you go. And then lastly, I have -8 and +3. That makes -5. And that would be my answer in standard form, all simplified. It's a binomial with degree 2. That's called like horizontally adding. You can also vertically add, which I'm going to show you with the next problem. So 8y cubed minus 4y squared plus 5, adding 6y cubed plus 8y squared minus 1. So again, when you're adding, you have to have that add sign in between. If you had the add sign in between, you don't need the parentheses. But this is going to help me do vertically. So what I do and what we're going to do is take 1, write it down. It doesn't even matter which one because it's adding, doesn't matter which order you add. And then you can put the other one beneath it, lining up the exponents. So 6y to the third plus 8y squared minus 1. And then this is called vertically adding. Then you can add down. 8 plus 6 is 14y to the third. Negative 4 and 8 is 4y squared. And 5 minus 1 is 4. Another way you can add vertically. So you can add horizontally, you can add vertically. Vertically I like, but sometimes it gets real complicated. Which is gonna be the next one. I think you still do it vertically. Three. Now I don't have a parentheses. I just have a bunch of stuff plus a bunch of terms. I can't say stuff, bunch of terms. You can definitely do this vertically or horizontally, whatever you like. I'm going to show you vertically again, just to get a feel for it. So x squared y, and then since we don't have parentheses, I'm just going to look for the other one. So I see these are like terms. So I'm going to put 10 x squared y under it. And then I'm going to look at xy. Oh, that's the only one, right? Plus xy. I don't have an xy. So I'm going to put a plus 0. I don't have an xy. Oh, yes, I do. Never mind. It's right here. I take that away. Another xy. And then I look for my y's, and I have a negative y and a negative 2y. And now I can add down. I have 11 x squared y. Notice how we don't change anything. No exponents change, nothing. You just add the coefficients and bring down everything else. Plus, that would be 2xy, and that would be negative 3y. And then you can do it horizontally as well. I tend to do horizontally, but some people really like the vertical. So if you like vertical, do it. It's actually really nice. You can sort of like, it keeps it very clear what you're adding when you do vertical, which we can mess up easily. I have done too when it's horizontal. Hey, I'm gonna give you one to try. You can do it any way you want. You do vertically or horizontally, whatever you want. Whoops, sorry. Should be n. All right, 2m to the fourth minus 8m minus 5m plus 1 plus n plus m to the fourth minus 6. Now, we haven't talked about this either. I want you to do it, but to be standard form, since we have two variables that are separated, we have m's and n's, it goes alphabetical order. So you do your highest exponent for m's, and then you go down and do the n's after all the m's. So give it a try. Okay, don't look unless you want to see the answer. I'm gonna write it down. Oh, I missed one. Yes, I did. No, I didn't. I did it one. Let me just make sure I did it right. Hold on. 5M, CLEM, then an N, and then, okay, that's what I got. So I put the m to the fourth together first, that's the highest exponent. Then I did the m's, the 5m was the only m. And then
Wouldn't it
I,
be -5, not -6, because there's a positive one in there?
oh, I missed that. Ah, see, I didn't cross it out. See, I didn't cross it out. Yeah. I missed it and crossed it out. Yeah, that's why I like crossing out too. Okay, -5, thank you. Now I can cross it out. So I just sort of did them in order. I did the m's first, I did the n, and the constant would always be last. It doesn't have it has a degree of 0. You don't know if it's an m or n. It's one of them, but degree is 0. So it's constant always last. Any questions on adding? So we're going to subtract next. So I think we're going to take like a 5-minute break. Any questions before we go? Now, 5 minutes means 5 minutes. I'm gonna, so at 3:25, I am starting with or without you. All right, take a break.